In this video, we'll discuss the energy critical infrastructure sector and cybersecurity. This video was brought to you by the National Cybersecurity Training and Education Center out of Whatcom Community College. NCyTE Center and this material is based upon work supported by the National Science Foundation. My name is Philip Kreger. I am a professor of cybersecurity at Embry-Riddle Aeronautical University in Daytona Beach, Florida, and also a co-principal investigator of NCyTE. Make sure to subscribe and hit the bell so you don't miss any of our videos. So we'll be covering a number of topics, including answering the questions: what is the energy sector? What is it comprised of? What factors affect the protection of the energy sector with respect to cybersecurity? What is the current state of protecting the energy sector? Cyber threats to the energy sector, the consequences of a cyber attack, and finally a wrap-up. According to the Cybersecurity and Infrastructure Security Agency, also known as CISA, there are 16 critical infrastructure sectors in the United States. The energy sector fuels the economy of the 21st century, and without a stable energy supply, health and welfare are threatened, and the U.S. economy cannot function. U.S. Presidential Policy Directive 21 identifies the energy sector as uniquely critical because it provides an enabling function across all critical infrastructure sectors. And those two words, the enabling function, is especially important because essentially what that means is that without the functioning of the energy sector, that the other sectors are not going to be responsive. So the components of the energy sector include such things as the power lines with which we are very familiar, the power plants that generate the power that is transmitted over the power lines, the cyber infrastructure that underpins it, including the computers, the networks, the people, and the sensors that bring us our power. What are the complicating factors in securing our energy infrastructure? And as we go through these, and if you've watched any of the other critical infrastructure videos, note that these factors pretty much apply to all of critical infrastructure. So the first one is the complexity of the energy critical infrastructure. The energy sector stands out as being particularly vulnerable among all critical infrastructures. This energy ecosystem includes things like the power plants that I showed you before, utilities, nuclear power plants, and something called the electrical grid. So what is the electrical grid? The electrical grid consists of the power plant that generates the electricity, which then is transmitted across the power lines that we saw before, and then it can be distributed to our homes and businesses. Protecting critical industrial control systems, operational technology, and the information technology systems from cybersecurity threats is a difficult endeavor. They all have unique operational frameworks, access points, and a variety of legacy systems and emerging technologies. If you've watched the advanced manufacturing videos, you know that we've already discussed these things called industrial control systems. But if you haven't watched it, an industrial control system is a collective term used to describe different types of control systems and associated instrumentation, which includes the devices, systems, networks, and controls used to operate and/or to automate industrial processes. To find out more information about industrial control systems, I would suggest that you go back and you watch the advanced manufacturing videos, and I will put a link to that in the description. Another term is operational technologies, which was also discussed in the advanced manufacturing videos. Operational technologies are programmable systems or devices that interact with the physical environment or manage devices that interact with the physical environment. These systems and devices detect or cause a direct change through the monitoring and/or control of devices, processes, and events. So essentially, we're taking computers and networking and software programs and pairing them with physical devices and sensors. So as opposed to the 50s and 60s when computers weren't that prevalent, now we have the convergence of information technology and operational technology. Another complicating factor is the interconnectedness of the energy sector. According to the former Chief Technology Officer of the Department of Energy, these 16 sectors are interconnected. That is, when a city goes out and people don't have food and panic and mayhem and pillaging and all that, you see the impact that not having energy or power can have on our lives. Again, remember that the energy sector is an enabling function, and so that if the energy sector goes down, if it's not reliable, it will then have a direct impact upon all of the other sectors. The vulnerabilities of the energy sector are of particular concern to national security due to its enabling function across all critical infrastructure sectors, with electricity and fuels used to power transportation, water facilities, hospitals, and communications. A successful attack on the nation's energy sector could snowball to affect many of these other systems. The age of the infrastructure is also a complicating factor. Much of the equipment that comprises the electric grid infrastructure is antiquated and needs updating. The grid itself is critical infrastructure comprising a network of more than 6,650 power plants, which are integrated via 450,000 miles of high voltage transmission lines. Estimates are the grid includes 70,000 transformer power substations and thousands of power generating units. The grid is mostly dependent on legacy technology. For example, 70% of transmission lines are at least 25 years old and approaching the end of their life cycle. And 60% of the circuit breakers are more than 30 years old compared to the useful lives of 20 years. So the real complicating factor is that while the infrastructure is antiquated, that it still works. We're still receiving power. But simply replacing infrastructure is costly and sometimes unnecessary. And you have to remember, as we've discussed in previous videos, that a lot of critical infrastructure is primarily composed of private businesses. About 80% of critical infrastructure is owned by private businesses. And you have to remember that businesses are in business to make money and to stay in business. So the saying goes, if it ain't broke, don't fix it. Now, another complicating factor that's actually related to the age of the infrastructure is the new technological innovation that is actually slowly replacing the legacy systems. So a government panel's overall concern that increased technological innovation could also increase the chances of a cyber hack. Weighing this danger against the need to improve service and convenience and update an aging infrastructure is a major concern of the energy sector. So while a lot of the infrastructure is antiquated, it is slowly being replaced by new technology. And ever since about the 1990s, as far as I can recall, is that we've talked about these things called smart cities. And these smart cities are going to be replacing life as we know it in this day and age of 2022. So what is a smart city? Well, a smart city is an urban area that uses an array of digital technologies to enrich residents' lives, improve infrastructure, modernize government services, enhance accessibility, drive sustainability, and accelerate economic development. Smart cities are the cities of the future. Governments in many of these smart cities tap into a combination of Internet of Things, cloud computing, artificial intelligence, augmented reality, edge computing, blockchain, and other cutting-edge solutions. Now, the reason that I bolded the Internet of Things, artificial intelligence, and blockchain is that I've already created videos discussing these. And so I'll put links in the description to these videos. But I think it's probably necessary to discuss at least somewhat the Internet of Things and how it relates to what we're discussing today. So what does a smart city look like? Well, we have things like smart energy. We have sensors for water quality. We have smart parking, electric vehicle charging, a smart home, smart buildings, smart environment, sensors for air pollution, sensors for electronic emissions, intelligent shopping, smart health. We're already moving in this direction. In the next few decades, what we'll see is that we'll see more and more technology being infused into our lives to make our cities and our homes smarter. But remember that this increased technological innovation could also increase the chances of a cyber attack. Every time you replace a mechanical or an analog device with an Internet of Things device, which is essentially a computer or a chip that has software that does something that is connected to the internet, it opens a threat vector for malign actors. Weighing this danger against the need to improve service and convenience and update an aging infrastructure is a major concern, as we've discussed previously. Remember that an IoT device is a computing device that connects to the internet. So what comprises the Internet of Things? Well, there's hundreds, thousands, potentially hundreds of thousands of different devices that can connect to the internet. Such things as smartphones. It's a computer with networking capabilities that connects to the internet. We have home assistants like Alexa. We have smart thermostats that we can connect to using a smartphone app so we can change the temperature in our homes even when we're not there. We have security cameras. We have things like smart appliances, smart refrigerators, and these things only constitute a very small segment of these Internet of Things devices. I did a network scan of my home network the other day, and I found out, I didn't realize it, that I had 16 Internet of Things devices connected at home. So what kind of smart devices do we have for the energy sector? I'm old enough to be familiar with these things called mechanical meters. And so there was nothing, these were not computerized and they were not connected to the internet. But essentially what these did is it would show how much energy you would use over a certain period of time. And you would have to have a service person come out and look at the meter and note it and take it back to the station so that you would be billed for the amount of energy you used. And then sometime these were replaced by electronic meters. But again, these were still manual meter readings, but it would require a person to come out and see how much energy you had used by viewing the current state of the meter. And now you have things called smart meters, and I've actually got one of these on my house. So these are connected to the internet, they're computerized, they can do remote recording, you can set dynamic electricity pricing, you can get real-time information on how much energy is being used. Again, this is really an Internet of Things device. It's a computer that's connected to the internet. And this is what one looks like. This is similar to the one that I have on my house. So you no longer need workers from the energy company coming out to look at your meter reading. All they have to do is pull it up on their computer because the meter is connected to the internet. What are the possible consequences of a cyber attack on the energy sector? I've already talked about this slide, but I want to impress upon you the importance of this is because the energy sector is a critical sector that provides an enabling function to the other sectors, that the possible fallout from a cyber attack can be catastrophic. Again, these 16 sectors are so interconnected. When a city goes out and people don't have food and panic and mayhem and pillaging and all that, you see the impact that not having energy or power can have on our lives. I don't know if you know it or not, but I live in Florida, so about once every 3 years, we lose power for about 3 to 5 days due to a hurricane coming through. And there's nothing we can do about hurricanes, but I can tell you it changes everybody's life when in that 3 to 5 days that we do not have power. So Lloyd's of London is a very well-known insurance company, obviously based in London. So they produced a risk report. A risk report from Lloyd's of London suggested that a successful cyber attack on the northeastern U.S. power grid that takes several weeks to fully recover from could come at a cost of between $243 billion and $1 trillion. Let's talk about the cyber threats to the energy infrastructure. Well, these threats and attacks are already here. In 2019, the Senate had a cybersecurity hearing where it was revealed that the Russians are already in the grid. So the Wall Street Journal published an article that the electricity grid in the U.S. has been penetrated by spies. Now I want you to look at the date of this article. This is 2009. The Senate hearing was in 2019. The Wall Street Journal noted that cyber spies had penetrated the U.S. electrical grid and left behind software programs that could be used to disrupt the system, according to current and former national security officials. Again, this was 2009. The spies came from China, Russia, and other countries, these officials said, and were believed to be on a mission to navigate the U.S. electrical system and its controls. The intruders haven't sought to damage the power grid or other key infrastructure, but officials warned that they could try during a crisis or war. The journal went on to say that the Chinese have attempted to map our infrastructure, such as electrical grid, said a senior intelligence official. So have the Russians. So what has changed since 2009 and 2022? Well, again, from the Wall Street Journal, it was reported in 2019 that America's electrical grid has a vulnerable backdoor and Russia has already walked right through it. America's electrical grid has a vulnerable backdoor and Russia has already walked right through it. Again, this is 10 years after the first publication in 2009. So a reconstruction of the hack reveals a glaring vulnerability at the heart of the country's electrical system. Rather than strike the utilities head on, the hackers went after the system's unprotected underbelly. Hundreds of contractors and subcontractors who had no reason to be on high alert against foreign agents. From these tiny footholds, the hackers worked their way up the supply chain. Those contractors and subcontractors who are working in the energy sector are part of that supply chain. Some experts believe that 24 or more utilities ultimately were breached. I have a series of 3 videos on the supply chain, so I suggest if you want to know more about that you watch those videos, and I'll put a link in the description. But just so it's a little more clear what I'm talking about, is that normally a government or a public service or even large companies don't do all the work themselves. A lot of what they do is that they subcontract work out. They subcontract the work as well as the employees. And so sometimes you'll see that, for example, with software development, is that they could acquire the software from a supplier, or they could use commercial off-the-shelf software and systems, or they could develop these systems in-house, or they could outsource them. And when it comes to the commercial off-the-shelf systems, that is something you can go off and buy that's already available. They could acquire that, they could develop an in-house, or they could outsource that, or they could reuse existing systems. With regard to developing in-house, they could develop that offshore in other countries. And this is actually a big deal because a lot of what is being developed by some of these government entities and government contractors is sent overseas. So parts of the system that are being developed are actually being developed not in the U.S., but overseas, or could be developed in the U.S. The problem is that contracting ebbs and wanes. It comes and goes. So a contractor one day may not be a contractor the next day and may be replaced by a different contractor either in the U.S. or offshore. And so it's almost impossible to keep track of all the potential cyber attack vectors for pretty much anything when it comes to computing. That's a quick introduction to the energy sector. And so we discussed what the energy sector is. We discussed the factors that affect the protection of the energy sector. We discussed what the current state of protecting the energy sector is. We discussed some cyber threats. We'll go into more cyber threats and cyber attacks in the next video. And we talked a little bit about the consequences of a cyber attack. And again, we'll talk more about that in the next video. And finally, we had this wrap up. This video was brought to you by the National Cybersecurity and Training Education Center out of Whatcom Community College.